right. Hello everyone. Good afternoon. As Audrey said, I'll be delivering this lecture today on the main data literacy course. And obviously I will see you in May in Gdańsk, but for now we're here in Malta. I'm from the University of Malta, from the Department of Geosciences. I know some of you because they're following our master's course. But the rest are, well, I cannot say new faces because I cannot see a lot of faces, just a screen with names. But anyway, if you want at any point, unmute yourself, say hello, all right, or ask any question you like. Audrey will be here looking at the chat. So if you don't feel for talking, but feel for writing, you can send something and she'll let us know. All right, so we can basically start by sharing my screen. I can share this thing. It's better like this so that I know what's coming. Slides. Yes. All right. And the whole idea behind this, I'm thinking we spend like an hour and 15 or an hour and 30 minutes, roughly in that kind of time frame, to discuss a little bit about the available online data portals and how you can access data. I know you heard about Copernicus, about ModNet, and they seem like these huge things or websites where you can download data. But the aim of today is just to show you how easy it is to actually download, and I show you also some software that allows you to interpret and process the data and extract some information out of it. I like to start with this quote, like the first one is data is acquired and prepared once to be used by many, right? And the other one is you cannot manage what you can't measure. And I think these two summarize a lot why it's important, to collect data, organize your data in a good way, so that others can actually use it. Because if you just collect data and leave it on your pen drive or on your laptop, right, it's basically useless. Collecting data is not always easy going. In fact, we try to do a little bit ourselves, and there's a lot of problems and challenges associated with it. But collecting it without sharing and without other people using it is kind of useless, right? So this is the aim of today's session. First of all, if I had to ask you, what about the mean sea level in the Mediterranean Sea in the last 30 years? Do you think it increased, decreased, or roughly remained the same? Like some silence, awkward silence to think about this. And nothing on the chat as well. All right, I think they're tired. I just need a coffee. Yes, but if you have a look at the trend, all right, so said, Helen said increase. Exactly. Thank you, Helen. If you have a look at the data for the past 30 years, right, you see that there's a positive increase with roughly 0.83 millimeters per year. All right, so plus or minus. So there's an increase of 2.5 millimeters per year, plus or minus 0.83. So again, all right, you cannot answer such questions without collecting the actual data set. All right, what about the sea surface temperature in the Mediterranean in the last 30 years? Do you think it increased, decreased, or remained the same? Drum roll. What did they say? It's increased. I think they're seeing the slide, the next slide, and it's true. I mean, if you have a look at the data, all right, we had an increase of 0.041 degrees with the data error per year. All right, so unless you measure and get such information, you cannot make such statements. The last one, the highest waves in the Mediterranean Sea. Do you think they're in the west, at the central, or at the east? Now this is a bit tricky. The others, let me do this. Maybe you could infer them, but what about this one? The highest waves. You have to look at the wave height in the Mediterranean Sea. Do you think they're more in the west side, in the center, or the east? Imagine you want to develop, I don't know, some converter to extract energy from waves. Where would you put it? What did the survey say? What?
East.
East. East. If we have a look at the data, you see that here on the west, there is some higher potential, all right? But again, without data, you cannot say such things. And this brings me to today's lesson, all right? How important data is and from where you can access it, because I know you're still doing your masters or your PhDs, and at some point you need to analyze some oceanography data, all right? So unless you can collect it yourself, you need to find some online source. And that's today, all right? We'll start with the Copernicus, then we'll discuss MODNet, and then I can show you also from where you can get some satellite data. And if we have time, we will discuss the World Ocean Database, right? So that's the plan. Obviously, when it comes to marine data, there are three major ways how you can collect data. There's in situ, so you take an instrument and you go directly to a particular location at a particular time, and you deploy your instrument. This is, of course, nice if it's done in summer, when you have nice seas and you get out of the office, but in winter, when it's got rough weather, it might be not so pleasant, especially if you don't like getting wet. But again, it's the most accurate way of how you can get data. There are a couple of instruments, but it's not the scope of this lesson to like discuss the type of instruments that we use to get oceanography data, but it's the first method. Then you have remote sensing. So in this case, we put the instrument on a hot air balloon or on a kite or on a plane or on a satellite, most of the cases. And this will allow us to see a much wider area. Right, so we collect data over a larger domain. And you have repeatability. So if you have your sensor is on a satellite, you know that every 2 days the satellite will pass from there. Obviously, remote sensing relies on in situ measurements for calibration. All right, so you cannot like obtain sea surface temperature or currents or waves without actually or chlorophyll without having an in situ measurement that gives you real-time data that you can calibrate your satellite with. And this you will see in Gdańsk when we do satellite derived bathymetry. So we try to estimate bathymetry from satellite data. Anyway, and then the last way of how you can get data is through models. All right, so these are numerical models that are able to forecast now, give you in the future the currents and the sea surface temperature and the salinity, etc. There are different types of models, like hydrodynamic models that are focused on the temperature and the currents and the waves. And then you have biogeochemical models that focus on nutrients, oxygen, chlorophyll in the water. So different kind of models, but they are able, numerical code that is able to produce a map, though still in 2D, but also in the future. Obviously, you can think that this needs to be validated, all right, first of all calibrated, and then it needs to be validated, and you validate models by using both in situ measurements and remote sensing. So although there are these three different ways of how you can obtain data, they are all required and all depend on each other. All right, so that's the nice thing here. Everyone will remain friends in oceanography, whatever you do. So today we're going to focus mainly on how to obtain remote sensing data and models. All right, you can see the mouse moving, Audrey. I think so. Yes. All right. Yeah, we're going to focus on these two. And with MODNet, you see how you can also get some in situ measurements. All right, so let's talk about this big thing called Copernicus. All right, the Copernicus, the Marine Environment Monitoring Service, sometimes also referred to as CMEMS. This is a free service. I know, I think last lecture they discussed this a bit. All right, but today we're going to get our hands dirty and show you how you can actually get data from Copernicus. Obviously, the idea is for maritime safety to get this marine resource for weather, seasonal forecast and climate, and for coastal and marine environment. So these are the 4 pillars upon which this Copernicus is based. It started off as a project, all right, and then it was My Ocean, and then My Ocean Next, and then My Ocean Follow On, and eventually it turned into a service, not just a product, but a service offered by the European Commission with all these data sources. Like instead of showing the slides, now I can stop sharing, and because I'm just sharing PowerPoint, I should share my entire screen. All right, and go to the browser. And if you go to marine.copernicus.eu, you'll end up in this window. All right, first of all, you need to register. Registration is free, and you can easily do it. Once you register, you can log in and start downloading data. It's when you're into this portal, you see these 4 buttons. All right, let us keep ocean products for later. Let's start with Ocean State Report. Ocean State Report, every year, Copernicus issues this report. they're on the 8th one now. We may say that the 5th one is the best one because there is our paper in it, but anyway. But last year they showed the 8th one, this year will be the 9th one. And basically, this is a report on what's happening in our oceans, right? You have, again, the full report is a bit big because there's a summary, so it's just shorter. There's a summary in French as well, right? But it's basically they take satellite data and models and they see what's happening and they issue this report. All right, so if you're like, I don't know, studying about sea ice or sea level, all right, there are different ways and there's also use cases of how this data is being used. So this is like a volume with different chapters of the state of the ocean, hence the name. Then if you just want the trends, and in fact, this is from where I got the previous graphs I showed you, all right, you can click on ocean monitoring indicators, which is the third button, and you have a summary like just the graphs of the parameters, how these are changing, all right? So basically what I do when I come here, I select the region, which is the Mediterranean Sea, and in my case, in our case, all right? And from here, you can have about seawater temperature, about the ocean heat uptake, the sea state, the chlorophyll, primary production, sea level rise, etc. So very good diagrams, especially if you're writing your literature review and want to compare your results, you can have a look at these indices. There's also global ocean, if you're interested in the entire globe, all right? Obviously, as we're going to discuss later on, if you're very specific, so if you select Mediterranean rather than global ocean, the advantage is that you get higher resolution data sets, all right? So the closer you get to your region, the higher the resolution of the data set. So that's why I start by selecting Mediterranean. This also, if I like let you in on a little secret, whenever like the press or are we invited on some radio show or something, and you know that you're gonna discuss, I don't know, sea temperature changes or marine heat waves or whatever, I like to first go here and the ocean state report, right, to get an idea of the numbers, because people like to hear numbers and make it relevant. And with this kind of information, you can quickly get a glance of what's happening and you can present this. But yes, so that's that as well. So but they're very good summary. If I forget to mention something, Audrey, feel free to pitch in, all right? Because this is a very quiet group. No one is saying anything. But even in the chat, no, it's like talking to my monitor for an hour. All right. If I get disconnected, probably wouldn't even realize. Anyway, so these are these two, all right? Then we have the third one, which is ocean visualization. And this is really nice because they present these three. So when you go to visualization, you present it with three options, if you like, all right? The first one is for kiddies. Obviously, you'll skip. But again, if you want to show something to someone, it might be really useful. Obviously, it's not working, but I think because I'm sharing the screen, because normally here you see data, all right? It's just like salinity or temperature. Let me see. No, I cannot see anything. It was working yesterday. But anyway, I think because I'm sharing the screen and it's taking some resources, Zoom. But anyway, so here you see the data. Let me see if the second one will work. Yes, this one works. Right, but here, just to conclude this, use basically see a globe, all right, with some animations of how the parameters vary during the year. So they're like monthly averages, all right, and you can actually see some pretty animations of you discussing, I don't know, temperature with someone or salinity, all right. You can actually show this. I suggest you try it. I don't know, maybe you're celebrating St. Patrick's Day today and you're going out later with your friends, while you can discuss this while having a drink maybe, but it's good, we'll see. Issa, then the second one is the intermediate phase, all right? So this now, if you're discussing something with like an undergraduate student or something, they're getting more advanced. And here is where you select you select the parameter you want, salinity, currency, surface height, or wave height, all right? And you get an idea of how these vary across the globe. So no animations now. Obviously, you can select a time, all right? And this is, for instance, every hour, so you can select exactly the time you want. And you can also zoom in. obviously here you start seeing the issue of resolution. All right, you see these boxes, every model or data that's coming from the satellite has a resolution, is on a grid. All right, so obviously the higher the resolution, so the more boxes you'll have, and so your data, first of all, it will look nicer. All right, and then you'll have much more data. So for instance, you can see the temperature here, you can see the boxes, you can see the salinity. Not all the products have the same resolution. All right, like for instance, if you go to wind, these are the streams, but you can see that these stream flows are based on the resolution of the data which is underneath. Yes, so again, a good interface. One nice thing about this is that if you click on any point, you get a time series of that point. All right, and this is super useful because sometimes, for instance, you want to investigate the temperature at a particular point. So you click there and see how this varies with time. All right, you can see the yearly cycle. So here's hotter in summer. And apart from that, since this is a model, data coming from models mostly, you can also see the subsurface products. All right, you can go to, for instance, minus 700 meters, or let's go a bit higher up, 400 meters. All right, so this is the sea surface temperature at minus 400 meters. So you can change this from here. Remember, with model, apart from the surface, you can also get idea of what's happening underneath. All right, at the subsurface layers. And this is a disadvantage kind of from satellites. Satellites give us only the surface. Now, obviously, you might be wondering why I have these black boxes here. That's because there is no sea at 400 meters. So this part is a shallow part. All right, it's actually, you can go to 100 meters to see it. I will discuss the bathymetry later on. All right, but like this, for instance, if we leave it to 100 meters, for instance, right, or a bit more, you'll see that there is no sea in this part. All right, eventually you'll see the bathymetry and you see that here is the very shallow part. Anyway, but whenever you click, you'll get a time series of that point at the depth you're at. All right, so quite interesting data. Also, if you're just interested in this time series, you can just download it from here. All right, if you're logged in, well, maybe in the other one. Here you cannot download, but in the advanced you can download. All right, so this is again a quick way of how you can get some data or some analysis. But the last one, which is the advanced one now, all right, it's exactly like before. So we have sorry, I zoom over Molt, all right, I'm a bit patriotic, but it's a good area to study. Here you can actually now change the layers, all right, so you can add layers as much as you want, and here we start going into the Copernicus catalog, all right, the data store. And here's where things start to get interesting. So remember, we're in the visualizing tools here, right? But you can select any product you want, and they have a lot of products, all right, more than 300. Again, mostly centered about models, numerical models, and satellites. All right, and from here you first I select the area I'm interested, Mediterranean Sea, so there are 56 products there. Then I select the variable I'm interested in, like temperature, and here are all the Mediterranean Sea products that give us temperature. Is some, you have to first of all check whether you want a model or a satellite. All right, if you're interested in forecasts to create a service, for instance, that you need to forecast how the waves are going to be tomorrow or whether to go swimming tomorrow or not. All right, so you need the sea surface temperature tomorrow. That obviously you need to go for a model. If you want past data, then you have to select between model or satellite. All right, so you have to make that choice. Is some Audrey, I can see a lot of things in the chat, but they are the names, just the names. All right, it's like doing the attendance. What else we can mention? I wanted to show PowerPoint again because here you can have this one. All right, this is about the resolution, what we've been saying. So if you have high resolution, you have a lot of detail. The lower the resolution, the less detail you're gonna have. All right, and that you find from Copernicus from here. All right, so this one, 0.042 by 0.042, that is the resolution, of course, in degrees. Now, it is a bit tricky of how to change this resolution to kilometers, all right, because it varies according to the latitude you're at, because the globe is a sphere. But roughly around the equator, 1 degree is around 111 kilometers, all right? So if you do 0.042 times 111, you see that this product is about 4.5, 4.6 kilometers. All right, so every box, that means that every box is about 4.6 kilometers. Fit this one. And then you can see this is again 0.042. This is 0.01. You see it improves. It improves this one. So the more resolution you have, the better. All right. Issa, be careful, because when you say low resolution, high resolution, it's not always the case that low resolution is not required, all right? If you're talking about global scales, like around the globe, you probably prefer to run a low resolution model because first of all, you're going to have a lot of data, all right? And it's better to produce a forecast with low resolution and it finishes computing in 3 days to forecast for the 4th day, rather than it takes like a whole week to forecast for the next 3 days, all right? Because otherwise it will finish processing after it happens. So sometimes, going for a lower resolution but across a larger domain is required. So remember this, all right? Because remember, at some point you're gonna have those tricky questions, all right, that you have to fill in. Low resolution is not useless, all right? Sometimes it is required. Yes, obviously also remember that higher resolution means more details, and also high resolution means more storage space as well. So it's not always like win-win to go to high resolution, but especially if you're in the coastal area, having a high resolution model gives you more details. So that's about models. Another thing about models is the forecast or reanalysis. All right, and what is this difference? And this is a big difference that normally I always ask in a Viva when they are like presenting this, and some students don't even like realize the difference or they didn't consider it. What is the difference? When you have an operational forecast that is giving you data every day, new products, new products, new products, right? That is the actual forecast. However, what they do every couple of months, Copernicus, is they take the actual observations, all right, the in situ observations that are coming from buoys, from ships of opportunity, from satellite, and they say, all right, so the model predicted this, all right, what were the actual observations? And then what they do is they rerun the model by assimilating this data in. All right, so they know what the conditions were, so they rerun the model with this data inputted in the algorithm. So now the model will be improved. All right, and that is the reanalysis. So if you want to generate, for instance, climatology, or you have an area and you want to like study the minimum and the maxima, or see the conditions there, the typical conditions, I suggest you go for the reanalysis because it's much more accurate. All right. If you want a forecast like what's happening tomorrow, you want, for instance, oil spill model, all right, you want to predict how an oil spill will move, then obviously you cannot rely on data which is like 3 months ago. All right, you need the forecast, you need the conditions tomorrow. So then you go for a forecast. In fact, this one is available until the 27th of March. If you see, Yara, this one is from the 1st of November 2022 to the 27th of March 2025. Now, just in case you haven't realized, the 27th of March is still not here. That's in 10 days. All right. So this is have a forecast of 10 days. It's called the forecast horizon. How far it's can predict 10 days. All right, then on the other hand, this one, which is again the same Mediterranean Sea Physics Mediterranean Sea Physics product, the reanalysis goes up to only the 1st of February 2025. All right, so we don't have March data yet. So this is the difference. Just in case you're wondering how they do it, like this is what's happening with data assimilation. All right, so here you have some in situ measurements such as CTD. This is an important instrument in oceanography. You lower it in the water column and it measures the temperature, the salinity, etc. We have also flows. Here you can see a very charming young gentleman holding a float and a drifter, all right? And we release these, obviously, in the area of between Malta and Sicily, the Malta Channel, and you measure a lot of data. So imagine this graph, all right? And the model, the first time you ran it, gave you the blue dot, the blue dotted line. All right, it predicted this line for one single cell. All right, because this is time. It predicted the blue line. Then you say, all right, Ara, at this time, I measured this value. At this time, I measured this value. At this time, I measured this value and this value and this value. So those are real measurements. So then you rerun the model, and this is like the reanalysis, the green one. All right, as you can see, it has the same trend as the dotted blue line, because the model, unless of course we're assuming it's validated and you have trust in it, the trend is there. But if you use the reanalysis, the green line, then it's much better. All right, so whenever you can, you should use the reanalyzed data. And then we have the satellites. All right, we have the satellites, and from here, for instance, we have this one. When you have the level 3 and level 4 here, it means it's a satellite product. And even if you read the entire title, it continues with the radiancy, high resolution, ultra high resolution satellite data product. Here, when it comes to satellite, you be careful about the level. So level 3 or level 4. All right, what is the difference? Well, I have a slide here to show you. Level 3 is the product with the missing data. So if there was a lot of cloud cover on the day, then you're going to get something like this. All right, level 3 with gaps. If you want gap-free data, so without gaps, then you have to go to level 4. But keep in mind that this data is interpolated or somehow filled in. It was not measured on the day, all right, but it's somehow filled in. There are some very fancy techniques that can fill in gaps nowadays, like for instance DINOF or other algorithms, especially that makes use of AI. But some scientists still prefer, if they're going to do some analysis or calibrate the model, then they prefer to do it on level 3 data, because they know that this data was measured, right? So with satellites, that's what you have to keep in mind. Actually, I had a video about Copernicus. Teach we see it quickly, and then we actually show how to actually download the data and process it a bit in Panoplia, right? So I'm going to share my screen because I forgot to tick this box to share also my audio. Share sound, optimize for video streaming. Share. All right, and we can see this. All right, be good this during the video.
Our ocean is vital for human well-being. The future of humanity strongly depends on the ocean's health and on our ability to monitor it. Did you know that the Copernicus Marine Services mission is to monitor the ocean? We provide 4D regular, authoritative, quality-assured information about the ocean, available for free and accessible from anywhere in the world. We distribute data from on-site buoys and satellites and from the latest science models in order to know more about the past, current, and future state of the blue, white, and green ocean. We make ocean data available that can be used to create applications for a wide range of actors in both the public and private sectors. We also support EU policies and international legal commitments related to ocean governance, catering to the needs of society at large. But you know what? We're not just a data provider. We also offer a large range of services for our users. Because our mission is to empower all users, from scientists to policy managers to private companies, who want to drive the blue economy and scientific innovation. We are there to support you anytime, anywhere, thanks to a dedicated help desk team, a chatbot, FAQs, a collaborative forum, and tutorial videos at your service. We organize events, webinars, and online training sessions to share scientific knowledge and promote sustainable ocean initiatives. And we continuously collect feedback from our users. We know one thing for sure: we need you. We need you to make the right decisions for the future. For a blue-green deal, a healthy ocean, a healthy planet, healthy people.
Episode 2 will come later on. All right, so back to our Copernicus, because now you're all motivated here. All right, so we discussed the different products. And so let's go to the download now. All right, so here you select, let me select satellite, ultra high resolution. All right, I do add to map. ISSAM. Every product So whenever you click on a product, all right, these will have like the layers, the data layers inside that product. Here we have 4, all right, 2 are with 1/100 resolution, the other one are 1/16. And here you have that this is sea surface foundation temperature and this is sea surface temperature anomaly, all right, so the difference. I'm interested in the sea surface foundation temperature at 1/100 resolution, not on 1/16. In fact, this is what it says in the title. The Mediterranean Sea high resolution is this one, 1/16. The ultra high resolution is the 1/100. All right, so I click on add to map here, and in the map, you can see the sea surface temperature of today. All right, so this is today, the satellite. Again, here you can see the resolution here is much better, all right, because it's ultra high resolution. Here you can see the color bar, and you can change it. There are some fancy, you can change the colors, you can change the opacity, all right, you can change whether it's stepwise or continuous. You can also change the range, all right, and this is especially useful if we have a reduced range, like in this case, like we can go to 10 to 18, for instance. All right, well, it's not really, I need to find a good color bar. But anyway, all right, so this is the temperature. And again, if you click on a particular cell, you get the time series, all right, of all the data layers you have here. All right, so this is a visual interface. Again, from here, if you're interested in this, you can just download it. If you're logged in and you click here, you can just download the data from there. All right, so again, these 3 interfaces are just to see the data. All right, you cannot really download it. If you want to download it, because like you're professional users, then back to the home page, you click on Ocean Products. And this is where it starts to get like super interesting. All right. Again, once you click on Ocean Products, you're presented with the same catalog now. All right. But now things will change, because now from here you can download the actual netcdf file. All right. You can actually download the numbers. And the nice thing about this is that it's set in a system that allows you to download the range of, so it's not just downloading a file with everything, all right? You can download just a subset of the data. You can download from one time to the other dates, or from one day to another. You can download the levels you want, so you can have full flexibility. So we want to download 2 products, all right? And in the next 30 minutes, I want to do this quick exercise. So we're going to download model data, so data coming from a model. And we're going to download the satellite data coming from a satellite, all right? And then we're going to use a software called Panoply to open these 2 data sets. We're going to select one cell, all right, and extract the values. And then using like simple Excel, we're going to see the values that the model predicted. When then we see the values of that the satellite actually measured, and we compare. And like this, we can extract quickly how accurate the model is. Or doing some quick model validation. So I think this is an interesting exercise. Let's do it quickly. So the first thing I'm going to select is go to the Mediterranean Sea. Select again, I'm going to select temperature, right? Because that's an easy variable. And I'm going to select, let's start with the satellite, the ones we've been doing, all right, before. And if you do view product, you're taken to the interface to visualize it like we were. I want to click on this small tiny arrow with a downward arrow on it. All right, you click on that one. And again, you're presented with those 4 options. All right, that we have. I don't want the anomaly, I want the degrees, all right, the actual temperature. And from here, I click on form. If you click on form, you end up in this nice interface, very useful interface. And here you have, these are the sub-levels. So you want the surface foundation temperature, all right, in Kelvin. You want the error. Actually, I don't want the error. I'm going to turn it off. I don't want the ice, and I don't want the composite mask. I just want the surface temperature foundation. I know that every time I switch off one of these options, or one of these parameters, because I won't download them, note here the size of the file. It will go down drastically. All right, that's why it's ideally you turn off the values that you don't want, so you don't waste space on your disk, and the file download will be much greater. Right? In this interface, yes, the only thing you have to remember is you can download files up to 1 gigabyte, 1.04 megabytes. Okay, so that's why you try to keep it minimized as much as possible. So that's the parameters. You selected the parameters. The next thing you can do is you can draw on the map the area you want to download. You see how customizable this is? So instead of downloading the entire Mediterranean, I'm going to download the area over around Malta here, and the file is just now 1.32 megabytes instead of 49 megabytes. All right. You can also type them. Imagine you're downloading data from different forecasts, as we're going to do. You can set these. All right. So here I'm going to select the north will be 35, 37.375. I just did this just to have a box around Malta, but to be constant. All right. So this is 735. The west is 12.713. The east is 15.655, and the south is 35.244. I wrote this down so that when we download the other product, we download the exact same domain, just because I have a little bit of OCD. But anyway, all right, so that we download always this box. And here is where you select the time range you want. All right, of course, this is the satellite, so it's available up to today. All right, the 17th. But I want to download data because I'm comparing it with the reanalysis. Shall we compare with the analysis? Yes, with the reanalysis. So I'm going to download data from the 1st of January to 2023 to the end of March. So 31/03/2023. So I'm going to download 3 months of data, all right, from satellite, and then I will download the reanalysis product. That's why I'm going like 2 years ago to have the reanalysis, all right? That's it. So after I fill this form, I click on download and the file is downloading. You wait a bit. All right, you can listen to some music or do something in the meantime, but it's here. That's why I try to reduce the sound, not the sound, sorry, the amount of space. All right, and then you download this netcdf file. I take it to my desktop. All right, Issa, note that to read netcdf files, you need special programs. All right, these are not ASCII program. They're not ASCII data. They're not like CSV files or DAT files that you can just right-click, open in TextPad, and you see them. They're binary files. That's why the file size is smaller and they encode a lot of information. So anything ending in .nc, it's a netcdf file. In oceanography, we like to use these netcdf files. Astronomers like FITS file, for instance, .fits. The atmosphere guys like grib files, .grb files. So everyone has his, his pick and mix. They're all binary files and they're all read by this software called Panoply. Panoply is developed by NASA. I gave you a link also in the slides here, just in case you want to download it, which I suggest you do. Do we need it for the yes, probably would need it at some point in Gdańsk, so might as well install it already. Yes, probably for Gdańsk you need Panoply, some other software, and the jacket because it's super cold, they told me. But anyway, so Panoply you download from here, all right? It's by NASA. If you go to Google and type download Panoply, it will probably come as well. All right, Panoply download. Yes, it's available for Mac and for Windows, so don't worry as well, and Linux. And once you load it, once you download it, you can just see Panoply, right? It's a very easy interface. If you click on the product I just downloaded, you get what we call the metadata here, right? All the information I have. So I have a file, a parameter time, latitude, longitude, and what I'm after, the analyze SST. All right, and they're here. And if I double click on analyze SST, which is a 2D product, all right, and create, I have remember the area I selected, the box, it is there. You see, that is the data in Panoply. And here, obviously, you can set the ratio for the width and for the height. So you can change these and so on. All right, so a lot of options. And here is the time. You see the time here are all the time frames I downloaded from the 1st of January till the 30th, 31st, I forgot. I think 31st. What is the last one? Let's see, 31st of March. All right. And if you go through them, you can actually see an animation of the sea surface temperature. All right, actually getting colder. All right. At some point, you can actually also see that the color bar won't remain valid because the color bar is fixed, as you can see, all right? If you want to change that, you can go here and automatically fit scale bar to data range so that it recomputes the color bar and just see again the values. So you see how easy it is to download and display NetCDF files. Then another nice thing is instead of plot, you can go to array. And here you have the actual values. All right. The NaN, obviously, it does not mean non-bread, all right? It means not a number. So sorry if you're hungry, I mentioned food, but which I am very much. But anyway, so NaN means not a number. All right, and obviously these are the different, the grid, all right? So you have the longitudes and the latitudes, and you have data for all these points. I show you something even cooler with this, but let's go again as a revision and download now from the reanalysis, all right? So back to Copernicus here, all right? Now I'm gonna go back to the data store, temperature is still selected, Mediterranean Sea is still selected. Before I downloaded this one, the high resolution satellite, now I want to go to reanalysis, not view product, because this will take you to the map and you say, oh, where I am here is not the correct place. You have to click on this arrow. You click on the arrow, and here, since it's a model now, you have much more parameters. All right, so you have the heat flux, you have the salinity, you have the sea level, you have the temperature, you have the these are the climatologies, all right? And each one is available in daily, monthly, or yearly, all right? Daily, monthly, or yearly. Some products are also hourly, so you have a value every hour, all right? Since the satellite is every day, one product every day, all right? Because to be honest, like this is not from one satellite, it's available because, you know, if you have a satellite, you have gaps in between the data, right? Because the Earth, when the satellite is going around, and these are all low Earth orbit satellites, so they're about 700 to 900 kilometers above the Earth's surface. And when they're going around, their orbit is about 90 minutes per orbit. The Earth also rotates them 15 degrees per hour. So you have gaps in the data. So they produce one whole gap-free satellite temperature, sea surface temperature product by combining data coming from different satellites. But anyway, but from model, you also have hourly. All right, so to be able to compare satellites and models, I want the daily, temperature daily, all right, not the hourly, the temperature daily. And I click conform again, and it's exactly the same one, all right? Here you have the bottom temperature or the seawater potential temperature. I want just the potential temperature. I'm not interested in the bottom here. All right, and here you give again, that's why I wrote them down. So here I can type them again and have the exact same box. So this was 737.735. This was 12.713. This was 15.655. And this was 35.244. All right. Audrey, by the way, is paying attention to the lesson. She's not playing solitaire, all right, next to me. So don't worry, she's done. She's behaving. Anyway, and here we can also do the range of values again. All right. So 1st of January 2023 to 31st of March 2023. All right. Again. No, this is interesting. Here, since it's a model, I can also select subsurface layers. Know that every time I select another level, all right, the file size increases. But since here we have quite a good internet, we can say what, download up to 500, all right, a depth of 500, so it's 83 megabytes, not that bad, all right? So I download, you wait, you can listen to more songs now because it's a longer file, a larger file, so it takes longer to download. All right, it says please be patient as well. And once it downloads, don't worry, if it takes more seconds, I can get the file I got yesterday, all right, as a backup. But let's give it some more time. It won't take long. But remember, Panoply, all right, just in case you get that nice little question, Panoply is used to view NetCDF files, all right? Wait a bit more. 83 megabytes. Well, it's not the download, which will take time. It's extracting this data, right? That I ask it to download, but it's there. All right. I again take it to the desktop to have everything organized with there. Right? And if I double click on it, it will open in Panoply. And here I have my other product, all right, with Theta AO. All right. And if I visualize it now, and I go closer, all right, this is my model data. And now know that apart from time, so I can go with time, all right, I can also go to different depth levels. And the deeper I go, I start losing the sea, because obviously it's land there. All right. So the distance between Malta and Sicily is what, 98 kilometers, and the depth at some points, as I'll show you on M1net, is quite shallow, like about 100 meters here. So very, very dark. All right, so this is the data set. So now let's do something interesting. And again, here you can see the actual values. All right, know that one is Kelvin and one is degrees Celsius, but don't worry, to convert them is easy. All right, here, just in case you don't realize, the latitudes are going up. So this is 35.27, this is 35.3, this is 35.35. So they're increasing. All right, but remember that if you see the globe, the latitudes go up as you go higher, right? So sometimes I like to flip the table top and bottom so that it's flipped. All right, so now it's more intuitive. So you have the high latitudes here and the low latitudes here. And in fact, you can actually see Malta. You can see the shape, correct shape, right? It's here. All right, just in case you didn't realize, Malta looks a little bit like a fish. All right, it's true. You see, it's like a fish. Here is the tail, here is the mouth. All right, and there is the fish. Our fish is there. Anyway, so apart from generating 2D graphs, all right, let's say I want to extract just one cell, all right? So remember, this is made up of a lot of boxes, all right? In fact, if I switch off interpolate here, I can actually see the resolution. Can you see the resolution here? It's these boxes, all right? You can actually somehow from here, scale to data range, from here, the ratio, right here, you can do width 100% and height 100% to see them boxes, not elongated like before. All right, let's say I want to extract the values of this cell. All right, just that cell. Let's say I want to extract the values at around 14.7. So Malta is about 14. All right, 14.5, 14.7 would be somewhere here. And 35.5 latitude, which is somewhere here. All right, because this is Gozo, this is Malta, and the 36-degree latitude passes exactly around here. Let's say I want just a cell, and I know the longitude and latitude. This is probably your region of interest or your cell where you took measurements, etc. All right, so here when you double click on Theta AO, instead of doing a 2D plot, you can do this one, line plot. All right, and you use the time on the x-axis. You see, the trick, a lot of people don't really know this, so you do the time on the x-axis. And here you have a time series of a particular point. All right, so obviously I want to stay at the surface because my intention is to compare this with satellite, so I cannot go deeper because satellite is surface. And here I select the latitude I want. All right, as I wrote again as just a particular point, I wrote 35.52. All right, so I find 35.52 here. All right, and then now it's taking all the longitudes and it's averaging the entire row, if you like. You can also remove the averaging and you select a particular longitude as well. And I chose 14.708. All right, know that this is the resolution of the model. All right, you cannot like select these longitude and latitude. This is who defined the model, specified the boxes. And he said, I have a box here, a box here, a box here. All right, it's a regular grid. So the distance between all of these longitude and latitude is equal, as we saw, 1/100 of a degree. All right, so, well, this is the model, it's a bit less. But anyway, that's for the satellite. All right, but it's a fixed grid. You cannot select any longitude and latitude. Once you do this, I say, oh, look what happened. The temperature here is a bit higher. And that you can select by going to plot. And again, like we did with the color bar, you fit the scale to data range and you will have that. All right. You see how nice? So this is the time series of a particular plot. I'm gonna make sure that I selected the correct one. So 35.528 and 14.70833. All right, that's my longitude and latitude. And once I'm happy, I go to array and I actually see the values. Here you have a parameter, which is the format of the values, all right? If you want exponent, for instance, or if you want floating points with 1 decimal place, that's why it's %.1f, all right? If you want, you know a little bit about Python or wildcards, then you can understand this. But my suggestion is either %1f, which is 1 floating point, either 2f, 2 floating points, or else %f, which is all the values it has available, all right? But let's fix two floating points, just 2 decimal places. And then what I'm going to do is I'm copy these values, go to Excel and paste them. All right. And this, remember, is the model data. Model data is there. And remember, we started from the 1st of January. Isma, Audrey, we don't have any questions. Oh, they're either asleep now or they're paying attention. So this is 02, 01, 2023. And I drag those. All right. And I have the dates and the model data. Obviously, you have to do degrees Celsius. Otherwise, your supervisor would be super angry without the units. All right. Then let's do the same thing for, are you excited, Audrey, for the result? We do the same thing for the satellite. All right. So analyze SST, again, line plot, again, against time on the horizontal axis, create. There you go. All right, now I have to view, where is it? I have the view of the, not this one, the plot. Where did it go? Window, window, window. There. All right, in Windows, this is fixed. You cannot change it. And in Mac, it's a separate plot. All right, but here I'm going to do the same. Is I have to select. Remember, this is a different data product. So the longitude and latitude will be slightly different. All right, they're still over the same domain I chose, but they're not exactly the same because it's a different data source. But you find the closest one. So here, 35.52. Let's find the closest one, 35.5208. So I have a close one. And again, for the longitude, before it was 14.70833. 14.708. Oh, I have a lot now. I have to scroll. 14.70 something. Coming 7. All right, this one is the closest. 14.7042, because before I had 14.708, so it's very close. And this is the time series from the satellite. What do? I go to array, I go to 0.2, and I just copy these. Copy. Where's my Excel? But I cannot see with this zoom bar here. And I paste it. And this is satellite. Remember, we're doing this for satellite. You have chlorophyll, you have water quality, you have salinity. You can do this, all right? Salinity, sorry, satellite data. Again, these are degrees Kelvin. So you know how to convert from Kelvin to degrees Celsius, Audrey? How? Minus 273.15. So we take this one and you do minus 273.15. You have 5 extra marks for knowing that. All right. And from this, I convert it to degrees Celsius. I do this. And there I have it. All right. What the model gave me and what the satellite gave me. And as you can see, they're very close. We check. They're quite good. So what you can do then is, if you want to be fancy, you draw a line chart. All right. So this is for the model. You can then on top of it, select data, add a data. Here you do satellite. All right, the X values, normally I do this. This I copy. And this I copy as well. And then I change B to C. All right, and there I have overlaid. So what I do is I remove the empty space so that you can see it. You see how quickly it is. In 20 minutes we did this very good analysis. 14. All right, and it's a time series of observed and model of the area you want. All right, it's a time series that interests us at a particular point. And as you can see, the trend is there, and it's quite a good data set. Moreover, again, if you want to be even super fancy here, you can do a scatter plot. All right, so you can do a scatter plot to see the correlation between the two. Technically, this should pass from the y equals x line. All right, it should be straight, but I do the oops, milt. So sorry, that's the Maltese. I said, oops, look what I did. So this is from 18 to what was the smallest value? Let's see. So we do 12, 14, yes, we do 14 there. All right, and then if I do it here as well, where is it? Where is it? Axis options. I like to do the same. All right, so that you have a y equals x line, and there you have it. You can also fit a trend line. All right, and it should pass from 0. And if I display the original chart, it's 0.9994, the r squared, right, which is quite good. All right, so this shows us that the model, to be fair, I use the reanalysis. All right, if I use the forecast, it would be a little less accurate. But if you use the analysis, it shows you that you're dealing with a quite good product, right? Actually, this product comes from CMCC, which is in Italy, and they're quite very good modelers. So you see, so this was a quick example to actually show you how you can download data from Copernicus and do something useful with it. All right. Again, we focused on temperature, but there are a couple of other parameters you can use. All right. So now that was Copernicus. Do we have any questions about Copernicus? Let's see. Still no? All right. Nothing? Nothing. All right.
You're clear.
I'm clear. All right. Or else they're gonna watch the recording later. The next thing I wanted to discuss with you guys is MODNet. All right, MODNet is another very important data source. By the way, yes, you can also, I give you some code here. What we did, you can also use MATLAB or Python to read the data computationally and read the netcdf. So I will share this with you just in case you're interested. But if you have to do this like for a lot of files, then you can do it programmatically as well, and it will be done in well, it's only like a few lines of code, and it will facilitate a lot of time. All right, keep in mind the difference in resolution. Obviously, with satellites you get much more. You're not seeing the slides. All right, sorry, you're just seeing me share my screen. All right, so this was the code I told you about in the MATLAB. All right, I will share with you just in case you want to run it. You can also write very similar ones, a similar algorithm with Python. And this is the difference in resolution, right? Remember, the model had a lower resolution than the satellite. But in fact, you can see the same, even mesoscale features, I would say, even in the model, you know, these mesoscale features, you still get, even though it's a relatively larger, lower resolution, and the satellite is larger resolution. But anyway, but yes, so this is the two plots. If we compare them in Panoply, we would have seen this. So let's discuss a bit MODNet. So MODNet was also started as a project. All right, it was a small project which grew, and MODNet is more about in situ data and static layers. All right, so you collect a data set. So with Copernicus, you have something operational, always coming. With MODNet, is more like fixed, consolidated data sets. So we have a question. Hey, yeah.
I understood that Copernicus only serves abiotic data. Is there also biotic data available on Copernicus?
Sorry, Samuel, what kind of data would you like? Like if you give me a parameter. But it's true, yes. It's mostly temperature, salinity, currents, waves. Maybe ModNet, you'll find that data here. I'll show you what's in ModNet. But there are a couple of parameters, but yes, mostly are related to that. There's plankton, oxygen, organic carbon, some nutrients, but these are coming from forecasts mainly, not even satellites. All right, you cannot get everything from satellite either, so there's the limits. There are some limits what you can get. Let's discuss ModNet. Maybe that will answer your question. So ModNet, they started as a project. Before they had different kind of groups. So you have the ModNet physics that uploaded data on physics. You have human activities. You had biology. You have chemistry. Now it's all as a single portal. All right, is ModNet. No, ModNet, that one. This one. All right, so everything is under this ModNet map viewer. And you can see my screen, right? Yes. And there is here you have the catalog. All right, you have ModNet biology, ModNet biology, like for instance, the occurrence data, we can biodiversity records. You have to give it some time. All right, it's not like things you have to select dates here. Well, there are some parameters, some data sources that are like that. Why is my internet so slow? All right, so this is but you switch on the layers you want. Here, I switched on under ModNet bathymetry. I switched on depth. I switched on this one, the mean depth in multicolor. All right, that's the one we're seeing there. It is the bathymetry we've been seeing. All right, and that is why I told you. Let me close Panoply. It's super slow. Please. I'm still connected already. Yeah, it's blank. It's coming. Here, there you go. All right, so you zoom in your area of interest. And as you can see, this is Sicily, this is Malta, this is bathymetry. And the nice thing about the ModNet, like for bathymetry, is this one. You can do an elevation profile, for instance, all right? So you can do a profile from here to here. And you can see that from here, it goes shallow, 100, 700, all right? And it goes to minus around 4,000, all right? So there's like we call it the Malta escarpment there, which is like, it goes super deep. Here, there's some interesting facts as well. Here, there's a Hertz Bank, just in case you know about. It's like a reef where all the cargo ships sometimes anchor there. All right, you see a lot of light pollution come from here. But also, you can see that Malta's on a shelf. All right, between Malta and Sicily, there's like a shelf, a very shallow shelf, around 100 meters. And that's from where, during the last ice age, some of the hippos crossed from Sicily, and we find remains over here, because that's where the bridge connects, all right, with Marsa Lock. Yes, so this is bathymetry. And the nice thing about this, again, is you can download all this data for free sometimes. And I get a lot of questions like this from where can I find good bathymetric sources? All right, so ModNet and GEPCO, just in case you heard about GEPCO, GEPCO uses this bathymetry. All right, with GEPCO, you also have land, you have elevation on land. All right, but the bathymetry, the C part is ModNet. This is the best bathymetric source there is. It's about 100 meters, the resolution. And they're always updating it, right? And you can download this. You can download this for free. Apart from this, there are also some other, a lot of other layers. All right, I was trying to show you the occurrences of where they found, all right, different species, and you can click on them and get all the information. Biodiversity records. I also like, because there are some studies that use them, human activities. There's the cables, if you like, power and telecommunication cables, all right, and the Mediterranean, like for power and internet. Again, these are shapefiles you can download. Desalination plants where dredging occurs. There's also one which I like, is this one. the route density. All right, so from where ships pass, like you take the annual totals, for instance, of all the vessels. All right, and you get a nice density plot of where all the ships pass. All right, and these you can download. You can download all this data. And yes, here you can see that between Malta and Sicily is quite a hotspot. All right, in fact, 80% of all cargo ships pass between Malta and Sicily, and also 20% of all dangerous goods. All right, so dangerous cargo. So we're quite in a hotspot, and that's why we try to have like very good oil spill models just in case something happens. But anyway, if you're selected, if you're interested in cargo or fishing or passenger vessels, all right, you can select the ones you want and download just that data set. Obviously, from here, now you're going to download sometimes an etcdf file, but also GeoTIFF files, all right, GeoTIFF files. And when it comes to this kind of data sets, these kind of data sets, you want to process them in a GIS environment, all right? I know there are a couple of GIS programs, there's Esri, but what we're going to use today and when I'm with you in Gdańsk is QGIS, all right? QGIS is a free GIS software. I suggest you install it, or on Sunday, no, according to the program on Sunday, we will make sure everyone has it on his computer. But basically, they had better to install before, but then someone will send them an email or something. All right, because it takes a while to install it. But this is GIS. Basically, it's like ArcGIS, but the free version. And basically, if you download this file from the bathymetry, I didn't show you how to download. Right, you go down here, downloads, and here you select the area you want to download. Like you do this, very similar to Copernicus, right? And here for the passenger vessels, because it's a GeoTIFF image, you just click on this link and you download it. For the mean depth, you select the type you want. All right, you select S3. You can also select NetCDF. This is the one I selected. All right, and you download the product. And then this will take a while because the data set is big. All right, but you get something like this. I'm on the bathymetry, you get this. All right, and then all you have to do is just drag it to your QGIS and you'll end up after a bit with your map. All right, it's loading, you can see here. All right, we're gonna use QGIS, don't worry, when we're together. And this is the map I downloaded. All right, then I also have a shapefile, which is the Malta coastline. All right, I think I have to, there you go. So this is Malta. All right, and here what you can do is you can, for instance, change the symbology. Go to properties, and from here you can do pseudo and change like the color scale that you like. All right, so use the color ramp, choose a nice one and apply it, and you get the bathymetry like that. I don't know which one you like, Audrey. Spectral. Can go that. All right, and apply. Another good thing that once you're here is that you can change the values of your color bar. All right, here the color bar is scaled from the minimum to the maximum value I have in my data set. But here you can say, all right, I'm interested in the top 300 meters. All right, the rest I can ignore. So I'm interested from minus 300 to 0. And when I click OK, all right, the color, I get more details in the area I'm interested in, because this is more than 300. But I can get, for instance, you see this bridge I told you before, you can see exactly from where it passes, or the walk that the hippos took. You can also see, for instance, here we have another reef where Malta once was thinking of an offshore wind farm. All right, Sikka Albaida. But if you zoom in, all right, you get more details in the region you're interested in. Here also is Filfla, for instance, a small island, etc. Right, but this is bathymetry. And again, if you want to load the the human activities, for instance, the vessels, all right, I downloaded some. You can just take the ones you want and put it there. Just drag and drop, and you get the ships. Obviously, here you have to do some processing, like go to stock and change the symbol. Let's leave them actually black and white. All right, and you start seeing the ports, because that's where you get most of the ships. Or you can even further refine it to 10 to see more details. All right, and then what you can do is you can change it to a some fancy things. All right, like pseudo color to get some colors like we did before. Oh, I have to change this again because my OK button is hidden. All right, there. And then what you can do is you can change the first one, the zeros, to a transparent one, so that you get something like this, all right, on top of my bathymetry. And you can do like a GIS things. Let's draw it. All right, so you have the bathymetry and then the ships where they go. I didn't download the entire data set, obviously. I downloaded a small section of it. All right, but you can see that you have the Grand Harbor here, all right, and the Malta Freeport, which is here, and a lot of ships pass from there. So this is also another important thing, that when you're processing this data, you think a bit and make sure that they make sense, all right, what you're seeing, not like random numbers or something. All right. So that was about ModNet. Then, because I promised them I will take 1 hour and 15 minutes to 30 minutes, so I still have like another 15 minutes maximum. I wanted to show you a little bit about satellite products now, like real muddy road satellite products that we get, all right? Not the products that are estimated in Copernicus, like the sea surface temperature or the salinity or the currents, but the raw products, like the visuals, all right? And for this, so we could cover the 3 things today. For this, ModNet, I also have another video, if you want to see it. It's called ModNet ingestion. Actually, let's see this, because ModNet, apart from the biology, the physics, the human activities, they have another initiative called ModNet ingestion, all right? And this is quite an interesting initiative. They say, listen, a lot of scientists collect data, like they do a survey, they collect data, all right, on a pen drive, and they leave it there in their office, they just use it. Why don't you share this data with other people, all right? And that's the whole idea behind the ModNet ingestion, all right? So let's see this quick video. I promise you it's not a long one. Hello.
Wake up your data.
Set them free at emodnetingestion.eu.
Here at eModNet, we share lots of data, 24/7 hard-working data. But there's some loose ends to be tied up in order to keep these networks strong and durable. We know there's still sleeping data out there. Good morning, government. Ahoy, Navy and offshore industry. Hello, NGOs. What's up, scientists and academics? There's a need for your old and recent data to strengthen Europe's marine open data network.
eModNet's data ingestion portal helps to wake up your data so it can serve blue growth. In the long run, this is good for everyone's figures. This data ingestion portal is a unique piece that funnels massive quantities of documented data packages, providing them with spick and span metadata. Using it is quick and easy, thanks to the straightforward submission workflow. In no time, you'll become the local data barista. First, grab your Marine ID to identify yourself. Next, submit your data package along with its metadata and relevant documentation. Continue by filling out the submission form. This pre-filled form provides feedback on the go. And although it uses controlled vocabulary, you don't have to speak Marinish fluently. One of the specialized data centers guides you through the submission process until everything is ready for upload. These data centers give feedback, verify your data packages, and tidy up their metadata. In addition to this quality check, they also provide safekeeping and further distribution of your data sets. That's right, every minute you invest pays off. There's even a help desk at your service if things get fuzzy, or in case you had a rough night, or your cat jumped out the window, or your friend flew in.
Well, whatever the cause, once your work is done, outstanding marine data infrastructures process your beefed up datasets and finally feed them into one of our thematic portals. EMODNet offers bathymetry,
Geology,
chemistry,
physics,
biology,
seabed habitats.
human activities, and coastal mapping.
No need to browse all that. Just use the Discovery and Access service as a bypass to your submitted data packages or to find more datasets and data products.
The Data Wanted service over here delivers data on demand. Tell us what you need, and if we don't have it, we'll try to find it and wake it up.
Thanks to this roaring ingestion factory, EMODNet can streamline massive data submission and finally turn data into value, while you get the credit and peer visibility. More than ever before, European marine data will work together.
Embrace the opportunity to contribute to Blue Society. Set your data free for others to work with, and you'll get a strong net in return. Wake 'em up.
At emodnetingestion.eu.
All right, so that was about EMODNet. So finally, yes, about satellite data. Oh, sorry, there's a question. Pangea. I'm not familiar with Pangea, Finn. But yes, it could be, all right? So that's the idea of having this portal. I don't know if Pangea is just about ocean data. Maybe you can reply, or send us a link to this Pangea thing and we can check it out. But yes, could be. I mean, I'm not familiar with Pangea. Is it an open data idea? Yes, so the idea is to share data. But maybe we can check it out. I don't know. Pangea. Yes, so satellite data. The European Space Agency launched, or is in the process of launching, these satellites, all right, called Sentinels. As we said, they're low Earth orbit satellites. So far, we have Sentinel-1, which is in orbit, Sentinel-2, Sentinel-3, Sentinel-4 not yet, Sentinel-5 also not yet, but there's 5P, which is the precursor of 5, and their 6 is also launched as well, Sentinel-6. And the nice thing is that they have 2 of every satellite, so Sentinel-2A and 2B, 3A and 3B, right? And the idea is to minimize the revisit time as much as possible. As we were discussing before, low Earth orbit satellites are quite low to the ground, right? Between 700 and 900 kilometers. They go around the Earth once every 90 minutes. So once, as I'm blabbing here, these satellites have done one whole revolution. What they're measured there in color is called the SWOT width, but they collect data as they go around, all right? Every day they do a couple of orbits. So this is day 1, all right? Second orbit, third orbit, fourth orbit, etc. And after 2 days, they kind of cover the entire globe. After these 2 days, then they start filling in the gaps in between, all right? And after 16 to 17 days, they go through the first orbit again. That's called the revisit time. So by doing 2 satellites of every mission, kind of 2A and 2B, 3A and 3B, all right, 1A and 1B, they halve this revisit time. So they pass through the same area much quicker, all right? There are 2 types of satellites. There are the optical satellites that work based on the radiation coming out from the Earth. So mostly they require the sun to work, they're optical. And there are the radar satellites that transmit a pulse and wait for the echo. All right, so these are echo sounders basically. Obviously you get different types of data sets. With optical, you get the channels for the red, for the green, for the blue, for the infrared. All right, things that you can combine together to do visual photos. All right, so this, imagine Google Earth photo updated every 2 days. All right, so those are the optical ones. And then you have the radar. The radar works on electromagnetic radiation as well, but they transmit a horizontal or a vertical pulse. All right, and they listen to the horizontal or vertical reflection. When it comes to the ocean, we are interested in the VV, so we transmit the vertical and we wait for the vertical echo. That is the most combination that gives us more information. So why is this necessary? Because imagine you have a spill, all right, an oil spill. Let's start without a spill, so no oil present, all right? You have this incoming wave coming from an active sensor, and it gets backscattered, it goes everywhere. You have backscattering. Some of this energy eventually manages to reach the sensor back, all right? So you get like an echo in a normal situation. When, however, you have some spill, so the sea is very, very calm, and it's like a mirror, all right, most of this energy is reflected, so no energy go back to the sensor. You don't have any incoming echo, all right, so it appears dark. You get a dark patch in your image, all right. That is probably because you have a spill. If you're in between, you also get the energy envelope is not so reflective, but it starts to get reflective, all right, and you still get some backscatter, but not a lot. So even if there's a small spill, you should be able to see it. Obviously, this is also true, like these two cases, when you have very, very calm conditions, for instance, or where you have biological films growing in your sea, all right, which is basically less than 3 meters per second wind. You can have very, very smooth surfaces and biological films growing, all right? So sometimes you do have false positives, and that's why you have to also consider the shape. But I wanted to tell you from where you can download such data sets, all right? For instance, if you're studying aquaculture and you see whether they are producing some spills, for instance, all right? So this is also interesting in that case. So to download this data, you go to the ESA data portal, the data space, all right? It's this one. It's also part of Copernicus because it's by the European Space Agency. So when you go to this dataspace.copernicus.eu, then you go to Copernicus browser here. All right. And you end up with kind of, as I said, a live Google Earth. All right. Well, the resolution is a bit lower here. We're talking about 10-meter resolution data set. But here is, if we go, for instance, 10 meter resolution. Here you see the actual days where we have the data. All right, so this is today in Malta, 17th. You can see we had some clouds, but mostly it was a nice day. Obviously, the Maltese students can confirm that. Then you have data wherever you have a box. All right, so here's last Friday. All right, and in fact, we had some wind during that week, so we have a lot of runoff here. All right, so like data in kind of updated regularly. Sometimes you have cloudy days, etc. So yes, so this is from Sentinel-2, all right? If you want to download data from all the other Sentinels, you can go to search and you download data from Sentinel-1, for instance, which is a radar, all right? A radar set, like an active sensor, or Sentinel-2, which is an imager, multispectral imager, all right? So a photo that I'm showing you, and 3 as well. All right, so they have the optical lens, color imager for chlorophyll, etc. So you have all these products you can download from here. To download them, again, you need to register. Very, very easy. And to download, then let me log in so that I show you how easy it is. I log in with my account. And then once you're here, you just say, I'm interested in satellite data over this part, the Marsa-Shlock part, for instance, in Malta. All right. And I want data from Sentinel-2. Level 2, because remember before I told you level 3 and level 4 for Copernicus, those are the products. Level 1 and level 2 are directly from satellites now, the radiances, not the products, the radiances, like the blue, the red, the green, the ones that you measure, all right? So level 1 are the raw data that's collected. Level 2 is that data corrected for atmospheric absorption. So you have some corrections there, all right? And then just you give the date range and you search, and from here you can download for free the actual satellite data. All right, you give it some time until it looks for all the products that go through this region I specified, and here you have all the data that you can download. For instance, this one. All right, you can click more information. So this was captured on the 25th of February, and you download this entire scene. All right, now when it comes to satellite, you're not going to download data over this region, the one that you specified, but over the scene, the entire scene. All right, but there, I wanted to show you that if you need to do this, it's super easy. All right, you find out of help, and even if you want to do it and you don't manage, you can always message me. Issa, what I wanted to show you here, there was a spill, all right, on the 7th of October 2018, two ships ran into each other, all right, so one was anchored and the other one was directly headed into it. These are some helicopter footage. All right. Funnily enough, this area, it was north of Corsica. It was declared a marine protected area a couple of months before, and then this happened. But what I wanted to show you is, I downloaded data from Sentinel-2, which is a visual satellite, as well as from Sentinel-1, which is a radar satellite. All right. Now you're not guaranteed, and this remember this one. You're not guaranteed to find the same day from the Sentinels, because you get the data whenever the satellite passes. All right. So you don't say, I need data for the 25th of February, because sometimes you get for the 26th, sometimes you get for the 24th. All right, so you're not guaranteed that day, but I got the data closest to the accident. All right, and then I'm going to load them on a program called Snap. You're going to use this with Jesus. All right, I think you had the lesson with last lesson was with Jesus. All right, but with Jesus, I think it's after me and the tutorial in Gdańsk. You're gonna do this, so you do oil spill detection. So that's why I wanted to rush through this, but to give you a feel of what can you use with this data, right? So Snap is a free software. In fact, Snap means Sentinel Application Toolbox. All right, it's by European Space Agency as well. And I'm gonna download. Well, I downloaded already, but I wanted to show you this one. All right, so this is from Sentinel-1A, this product. And this is from Sentinel-2A. Remember, 2 is the visual one, and Sentinel-1 is the radar one. All right, so if we load this in Snap, you again wait a bit. I don't know why I loaded another Snap here, but anyway, it's reading. Another important thing. Remember that the Sentinel satellites were launched by the European Space Agency, ESA. All right, this is another good. Actually, I mentioned 4 important things, and they have 4 questions. So good. Yeah, we wait a bit more for the Sentinel-2. The computer is getting tired. But anyway, so we have Sentinel-1 already here, all right? So I can see the bands. The bands here are those vertical, transmit vertical and wait for the horizontal, or transmit the vertical and wait for the vertical. All right, and this is the actual satellite radar image. What I wanted to show you is the spill. All right, so this was for the 8th of October 2018. All right, and the other one, the visual one from Sentinel-2, which I can now open RGB image and create it, was for the 9th. All right, so one for the 8th, one for the 9th. This is Corsica. Here are the 2 naughty ships. If we zoom on them, all right, those are the 2 naughty ships. And you can see a thread here, but it's not that strong. You won't even realize, all right, unless I told you. You just see something there. All right, so this is the normal photo that we see. All right, very nice resolution of Corsica. Anyway, very nice. All right, it's high resolution, but the naughty ships are here. You can see some other gossip ships going to see what's happening, etc. But if we see the same image from a radar, you see how much better we can actually see the spill. You see? And then obviously this is just the raw data, right? I can play a little bit with sliders and even improve this. You see how much more contrast I have? And I told you before that, look at the gossip ships, how many are 1, 1, 1, 1, 1, and they're going to see what's happening. But this is why I told you active sensing is sometimes required, especially for these kind of activities. And also, before I mentioned that you can have a lot of false positives, like very calm waters or a biological film. But this, when you correlate it, all right, you correlate the shape with these things. So this is definitely a spill, because there's the trail, there's the shape that gives it away, kind of. All right. Yes, so this is it. Also with the snap, you can also calculate chlorophyll, for instance, all right, from which you can get like the runoff, etc. I also prepared some notes on Ocean Data View, but I think they have a full tutorial much back, like when we go to Gdańsk on this. So I will leave it to I think done by the Gdańsk people themselves.
Yes.
Ocean Data View, so they'll be home, so better not reveal any secrets. All right, so I know it was like a fast-paced 1.5 hours, but at least we went through a lot of things. All right, we discussed, first of all, the kind of data set that you can download. Then we focused on Copernicus, which is basically a lot of oceanography data sets there coming from models and satellites. And then we went to ModNet again. And we saw Panoply to read these NetCDF files. Then we moved to ModNet, and we saw how you can download some NetCDF files from there as well, and how to process them in a GIS environment like QGIS. And finally, we saw like remote sense data, how you can actually get the raw data and how you process it using the Sentinel application toolbox. So I hope you found this interesting, and I don't know whether there are some more questions. Or doesn't look like it. You're a quiet group.
Of course, like Alfredo said.
Wait, you have to unmute, or they can hear you, I think.
Okay. Like Alfredo said last week, it would be a good idea if you experiment with these tools.
Yes, of
before
course.
we go to Gdansk.
Yeah. All right. Welcome to my tutorial. Yes, we go step by step. So that's what we'll do together in Gdansk. We will download some satellite data, and we'll try to estimate the bathymetry from the red, green, and blue channels. We get the bathymetry over an area of interest. All right, so I can see some people saying saying thank you for sticking around for 1.5 hours. I hope to see you soon in Gdansk. All right, unless there are other questions, have a very nice evening.